a system, there are so many factors affecting it, like the process variables. And when you decide to change something in the system, all the other parts are affected, and that could cause some problems. You need to keep in mind what goes on in your process system. I also learned that in process control, as the measure for safety goes up, it becomes more costly. So the best choice is to invest more in the necessary controls like DBCS to avoid having to spend on higher level process controls. I didn't think that anything could have been discussed more. The lesson seemed interesting and it really gets you thinking. I liked how it was presented in class because several cases were given and Sir Joseph asked us what the controlled, manipulated, and disturbance variables are for each case. And it was really interactive, and it also tested us we were if we understood the lesson. Since the three thermal science disciplines and four basic laws are already familiar to me, what I learned new is that they can all coordinate to make thermal systems engineering. In chemistry and physics, these topics were discussed separately, but here they are combined as one. And the conservation equation, material balance, energy balance were discussed once again. And I didn't find this field as interesting as the others, so I can't think of what should have been discussed more. The presentation was okay. Sample cases were also given, and we tried solving them in class. There was also a homework wherein the final answer was already given, but we had to figure out how to solve the problem and come up with that answer. For this, I think it's nice that when this was discussed, we just finished the lecture for electrochemistry for Chem 17. So we had some background on the topic already. And out of the three fields, I found this the most interesting because we performed an experiment on this in Chem 17, and from what I remember, we also did it in high school. So some slides had familiar information like redox reactions, electrochemical cells, thermodynamics, Nernst equation, kinetics. What I learned new is its application since we focused more on the concepts in Chem 17, but several examples were presented in class. It was my first time knowing about the chloroalkali industry, how copper wire is made because we commonly use it in the lab experiments, and the fuel cell car. That's a really innovative idea, and like that is the kind of project I wish to work on in the future, innovation. So the presentation was good, most especially that videos were shown to get a better picture of how these industries operate. And I wish that batteries could have been discussed more because it's one of the most basic applications of the field, like how batteries are made, and there should be a video about it as well.